magnetic storms may well be able to bring civilization to a standstill. If it weren't for the protective power of our planet's magnetosphere. If Earth has a magnetic field, do other planets? It's a vital question, according to NASA, because other planets' magnetic properties may reveal the future of Earth.
1, 0, liftoff. We have a liftoff.
Only with the beginning of the space programs in the 1960s have we been able to detect the magnetic fields of other planets. And the discoveries are surprising.
All 4 of the giant planets, Jupiter, Saturn, Uranus, and Neptune, all have actively generated magnetic fields today. Jupiter's magnetic field is the strongest in the solar system. Its surface field is about 10 times the strength of the Earth's.
Jupiter's magnetic field stretches over 4 million miles from its surface, and it performs the same function as Earth's field.
We see northern lights on Jupiter and Saturn, which is exactly the same interaction that we have northern lights on Earth. It's particles from the sun being focused to the poles of those planets by those planets' magnetospheres, and they light up the atmosphere just like they do on Earth.
But closer to the sun, planetary fields are mysteriously less common. Mercury has a very weak magnetosphere, about 1% of Earth's. Venus has virtually none. And the most mysterious of all is the red planet, Mars.
In the late 90s, the Mars Global Surveyor spacecraft, which was in orbit around Mars, had a magnetometer aboard. That magnetometer found that Mars does not have a global magnetic field.
But the Mars Surveyor found evidence of small magnetic fields scattered on the face of the planet. NASA believed it was paleomagnetism, an ancient remnant from a period billions of years ago. Did Mars once have a magnetic field rivaling Earth's? And if so, what happened to it? Fortunately, we don't have to go to the red planet to investigate, because pieces of the red planet are already here.
We actually have samples, rocks from Mars. They're meteorites. They were blasted off of Mars by an asteroid or comet impact millions of years ago. These rocks wandered around in space, and then some of them landed on the Earth randomly.
One of these Martian meteorites is actually famous. ALH 84001. Some scientists have suggested it contains the remains of ancient Martian life forms. Whether or not this proves true, this piece of rock may answer the question of Martian magnetism.
ALH 84001 is the oldest known rock from any planet, and it is a unique sample from Mars. It lived through the earliest epoch of Martian history. So this sample has all kinds of fascinating records in it.
MIT's superconducting quantum microscope, or SQUID, is one of the most sensitive magnetic detection devices on Earth. A sample from the Martian meteorite gives up startling results under the SQUID lens.
We showed that this rock is magnetized, and the magnetism, the paleomagnetism, has been very precisely dated to be about 4 billion years old.
Beneath the surface of the meteorite is the ancient record of Mars' magnetosphere. 4 billion years ago, a strong magnetic field was generated by churning magma in the planet's core.
Early magnetic Mars was a fundamentally different place than the one we see today. The atmosphere, we think at that time, was much thicker than it is today. There was probably water flowing on the surface. Temperatures were warmer. So it was much more Earth-like.
Then, mysteriously, Mars died. Temperatures dropped. Water vanished. the atmosphere disappeared. What happened?
Mars' magnetic field died sometime around 4.1 billion years ago. What's really fascinating about that is it seems to be roughly coincident with the time when Mars began to change from an early warm, wet state to its current cold and dry conditions.
One hypothesis for why Mars' atmosphere disappeared was because it didn't have a magnetosphere to help protect it. So the solar wind was constantly stripping away parts of the Mars atmosphere.
Without magnetic armor, a coronal mass ejection would bombard Mars' surface, a magnetic hurricane that would tear away the planet's atmosphere.
Suddenly, the atmosphere was losing large quantities of gases like oxygen, argon, nitrogen. The atmosphere got thinner over time. Liquid water stopped being stable on the surface, and Mars kind of went into a stasis, a cold, dry stasis.
But could it happen on Earth?
Certainly, at some point, the Earth's magnetic field will shut down, but that's a long way off. A more immediate issue is when will the Earth's magnetic field reverse?
As we saw earlier, our planet reverses its field every few 100,000 years, and we're overdue. When the Earth's magnetic field reverses, the process may leave Earth without a protective magnetosphere for a period of days, or even longer. This could lead to the very real possibility of the Mars scenario.
We're going to see magnetic storms like we've never really experienced since modern civilization.
But we don't need a planetary reversal to wreak havoc. Experts say our entire society could be destroyed by a magnetic storm. Planetary disaster might be avoided, but steps must be taken soon. And the clock is ticking toward magnetic apocalypse.